then if anyone has anything to share from the last topic or the last class, it's time you can share with the class. Does anyone have
Trying to
anything
see
to
if you
share?
accepted my invite on GitHub.
Mm. Your invite, I think I should have. I've accepted all the invites that I saw, except maybe I skipped it. But maybe after the class, I will check again. And I've seen that some people are really putting a lot of work, which is quite encouraging on GitHub. So,
Yeah.
but in terms of solving the problems, is there anyone that anyone had a challenge with?
Well, lot of challenge, but we had to figure out a way around them. I don't know if anybody is talking anyone though. So far, it's been interesting. Very interesting.
Okay. All right. So let's go into the topics for today, which I have outlined here. Since nobody have any thing to say about the exercises, I haven't taken time to look at the GitHub accounts, how they were done. But I just breezed through and saw that some people have done a lot of work. Some have stopped at the chapter before the last one. I've not seen their commits on the last chapter. So today, following the book we are following, we are in chapter 5. Okay. It's titled Miscellaneous Topic. Here there are some key techniques, what I would call some approaches that are discussed in this chapter, which will come in very useful to us while we solve problems. And then I listed them from the chapter here. We have the counting, how to count items. We have summing, how to sum items, swapping, flag variables, maximum and minimum, comments in Python. And then we look again at simple ways of debugging. Okay, so when we talk about counting, the whole idea is that you're trying to keep track of something. You're trying to count them. For example, if someone says, count for me all the numbers divisible by 7 between 0 and 100, you can use this to keep count of them as you iterate. Maybe using your for loop, you go through 0 to 100, you check all the numbers. Then once you see the one that is divisible by 7, you count. Usually in our code, we go like this for maybe I in range 100. Say we are just trying to find the numbers that are divisible by 7 in, let's just say 1000, right? From 1 to 1000. So I put my for loop and want to generate the numbers in that range, starting from 1 and ending in 1001. Okay. Because when you do the range, it will start at 1 and to end in this range now to end in 1000 exactly. That's why we added 1. So that's say 1001. So for I in that range, you could check if it is if I mod 7 is equal to 0. Yeah, I think we touched on the module.
Yeah.
Gives you the remainder. So you say if the remainder is 0, then you want to count those items. Now, the key thing about this counting is before you enter into your loop, you need to initialize the count. Say, if I call it count, I would need to say is equal to 0. Okay, so that whenever I see a condition where I is divisible by 7, then you have count, also count plus 1, right? So you have count equals to count plus 1 whenever you have divisible by 7. Okay. Now, the reason why you have to initialize the count here is because the first time we are calling it in our loop, watch very well what we say, count equals to count plus 1. So at this point, you're saying the previous value of count, and then we increment it by 1. Now, when you do this, if you have not initialized count before, it's going to generate an error because you're trying to compute something that you've not created. For example, if I make this a comment, so there is no count initialized, and then you just attempt to do this, let's see what will happen. So I save it, and then I run the code. Where is it bringing around from? Okay, you can see it doesn't understand what count is, right? The name count is not defined. Did you mean round? Because on this line, it is attempting to use count and it does not know what count is. So it's not defined. Before you use a variable in a computation, say in the right-hand side of your equation, you needed to have been defined. It needs to have a meaning first. So Python now trying to do this on line 6 is encountering the error. It does not know what count is. That's why before you come into your loop, you usually would initialize count. And we initialize count as 0 because yes, we're starting from 0. Okay. And then with this, we can now save it again and try it. Aha, I did not print it, so nothing showed. So after counting, I come out of the loop and print count. Okay. I'll print count, whatever it is. Let us see. Now I run it. So you see there are 142 numbers from 1 to 1000 that are divisible by 7. Okay. So whenever they tell you to count maybe numbers that whatever, just count something, you need to follow this kind of approach where you define the variable, the count variable, and keep incrementing it each time that the condition is met. Count equals count plus 1 in Python. Another way to write this count in Python would be this count plus equal to 1. Now, these two, they mean the same thing in Python, right? This is just a simplified version of this line 6. Okay? A simplified version of line 6. I'll turn it to a comment, but I just kept it there. So you see, there's another way to write count equals count was 1, which is that. So this is the way you approach counting. So from time to time, maybe when you're solving something, you want to count whenever certain event occur, you can use this approach. Does anyone have any questions so far? Now, the other addition to this is you could use similar approach calling a variable like this. If you want to be subtracting, maybe each time something happen, you want to minus 1, you can still have something like this. You can still have maybe your count equals count minus 1, right? If you needed maybe to be subtracting the count. And this also still has a short form in Python as count minus equal to 1. Okay. Same approach, you can have multiply, divide, and so on as just those common operators. Okay, so that's for counting. Now, similarly, we have summing. Let's say we want to add all the numbers between 1 to 100. If they tell you to do that, you can follow it, just a similar approach. Let's say maybe some odd. I want to add all the odd numbers. I'll initialize it to 0. And then I run my for loop again like before for I in range 100, right? 100. Let's say from 1 to 101. And I want to sum odd numbers. So you use your if statement. If I mod 2 is not equal to 0, because if I mod 2 is equal to 0, it's even. And whenever it's not equal to 0, it's odd. You can then see have your sum odd being equal to sum odd plus I. Remember, in this case, I'm not just counting by increasing it by 1, but now I'm adding I from the loop, right? So anytime the number is an odd number, I will sum it. Sorry. Okay. So we are summing it. So if you have 1, it will add up 3, 5, 7, 9, and so on and so forth. Just similar to counting, similar approach. But this way now you can keep summing things up and maintaining the sum in a variable. But remember, before you have an equation like this, you must have defined what sum is. So that's why we can
No, I'm okay.
Is it clear? Is it clear?
It's tricky. It's tricky.
Okay. Do you want me to go through it again?
Yes, especially the difference between both usage.
No, if you look,
Yeah, it's obvious, but using either of them is where the confusion lies.
So, okay, one thing in coding is what do you want to achieve, right? That's what guides what you do, your end goal, what you want to achieve. So in the first instance, we just want to count. whereby whenever a condition is met, we would say 1, 2, 3, something like that. Just keep adding. When you're counting, you're adding 1, 1, 1, right? It's similar to summing. Instead of just adding 1, 1, 1, in terms of summing, you're adding the variables you want to sum. You're adding them. So if I ask you to sum, let me say, you have 1, 2, 3, 4, 5. Somebody say you should sum it. What the person wants us to achieve is 1 plus 2. The first time, maybe if I said sum, S is equal to 0, right? I started by that, and then I want to sum it. So what I will have is S equal to S plus 1. Initially, S is 0, so this will be 0. 0 plus 1 is 1. Then S will now be equal to 1. So the next time you come in your for loop, let's say all of this is in a for loop. Here, by this time, we are summing inside the for loop. So the first time, S is 0. So when you call it S plus 1, the first element is 1. Assuming your for loop is bringing 1, 2, 3, 4, 5 to you, and you want to sum it. So you define this as 0, the first instance. So the second, when you're in the loop, it will be 0 plus the first item, which is 1. The answer will be 1. By the time you run the second iteration, S will be equal to 1. Remember, the first sum, it was 1, plus the next number is 2. So that's 1 plus 2, which will be equal to 3, right? And then the third time in the loop, S will be equal to 3 plus the third number is 3, which will be 3 plus 3, which will be 6. I don't know if this explains it better. So you continue like that. The fourth time, S will now be equal to 6 plus the next number, which is 4. 6 plus 4, which will now make it equal to 10. So by the next time, when S is 10, which will be like the last time, so we have S is equal to 10 plus 5, which will now be equal to 15. I don't know if this makes it clearer. Hmm? Does it make it clearer?
This is for the sum, I guess, not the count.
Sorry, take that again, please.
I said this is for the sum, not the count, right?
Yeah, not the count.
Okay.
And it's just almost the same thing, you know. In terms of the count, instead of us to be adding 1 and then the next time we add 2, the next time we add 3, what we are actually adding is 1 every time.
Okay.
Similar logic, because when you're counting, you're just counting, 1, 2, 3. So each time you see the item, you count. Like the example we gave now, we are trying to count how many numbers are divisible by 7 in this range. So anytime the number is divisible by 7, count, you take the previous value of count and you add just 1. You take the previous value, then you just add 1. Just keep adding like that. But then in summing now, you're not just adding 1, you're maybe summing, like in this case now, you're adding the loop variable I anytime it is odd. Okay. Now, these kind of concepts, you will see them come out to us in different questions. Let me look at the text again, and then see if we see a question where we need to sum in the Now look at this first question in the exercises. It says, write a program that counts how many of the squares of the numbers from 1 to 100 end in 1. Okay? Write a program that counts how many of the squares of the numbers from 1 to 100 ends in 1. So what it's telling us to do, we'll take 1, we'll square it. Square of 1 is 1. It ends in 1, so it's among. You take 2, square 2. The answer will be 4. It doesn't end in 1. You would not count. This one is more of count, right?
Yeah,
so you just find a way to check if the last digit in the number is 1. That anytime the last digit in that number is 1, you will increase your count by 1. Okay. So the challenge in the question now is, how do you check if the last digit of a number is 1? That will be the challenge in that question. Once you figure out how to check the last digit is 1, then you can always just apply similar counts to what we've just done and keep incrementing it. Okay? You see, number 2 is still count, but number 3, I think it has to do with sum. So say write a program that asks the user to enter a value n and then computes 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 until 1 over n. So it's like summing of these numbers. So instead of you to be counting every time adding 1, now you're going to be adding 1 over 2. The next time you add 1 over 3. The next time it will be 1 over 4, and so on and so forth. So to solve this problem now, you need to just get the sequence. If you watch very well, this is 1 over 1. So let's say you have a for loop running from 1 to n, because the user will give an n. If the user gives an n of 5, so you're going to see something like this. If n is 5, you have 1 divided by 1 plus 1 divided by 2 plus 1 divided by 3 plus 1 divided by 4 plus 1 divided by 5. Now, 1 divided by 5. Now, what is changing here is the denominator. So the first time, the denominator is just like when I is equal to 1. The second time, I is equal to 2. So from your for loop, you already know if I do a for loop like this, for I in range, say 1 to n plus 1, whatever n the person supplies, so plus 1, so that you can get the actual value he supplied. Let's say he supplied n, say n is equal to 5, and then you have this. So you then have a situation where you're talking about summing. You have to initialize your sum to 0, for instance. And then here, you still have the same sum norm should be equal to sum norm plus 1 divided by I. Okay. So the first time I will be 1, the second time I will be 2, 3, and so on and so forth. Something like this. So you're summing. Do you get? So these are the ideas now you will use in answering those questions. Here you see, write a program to compute the sum 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8, blah, 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 till 2000. How do you configure this? It's still summing to compute the sum. So you have to sum it somehow. Your loop will generate the numbers for you. Then your sum will compute the sum. I don't know if the summing and counting is clear at this stage.
Yeah, very clear.
So by the time you deal with these exercises and try to do the actual sum, you will see that you just need to bring some logic. Everything you learned, we're using your for loop, we're using our if statement, we're bringing them together to make something happen. Okay. That's it. So these questions are there to make you think and apply them. But then you just be applying these concepts, sum, count. Now we'll move on to the next one. Let me remove all of this. And we talked about summing. Now we talk about swapping. So there are some instances where you need to swap numbers. Like I think one of the questions we've seen before has to do with Fibonacci, generating Fibonacci sequence, where they'll say something like the current number is equal to the sum of the last two numbers. So there's one way you can approach that problem and you have to swap. What does swapping mean? You have x maybe equal to 3 and you have y equal to 7. But you need y now to be equal to the value of x, which is 3. And the x should be equal to y, something like that in Python. How can you swap? One way to swap is you bring in a temporal variable. Because if I say temporal now is equal to x, what I've done now, I've taken the value of x and stored it in temporal. After I've done that, I can then say that x is now equal to y. Okay? To make sure that here now, let me put a comment. Temp is now equal to 3. From the next line, x has changed its value and is now equal to 7. Then I can then say something, oh no, and enter. I can then say y is equal to the temporal variable, which I use to hold the value of x. So I don't lose it when I make x to be equal to y. So as not to lose it, I stored it in temp. Now that x has changed value to y, I will then say y is equal to temp. This will now make y to be 3. So with this approach, we have succeeded in swapping these numbers. Now, someone may attempt to do it without storing this in a temporal variable. The moment you say x is equal to y, you have lost the former value of x. So you can no longer do any other thing. That's why we put it in a holding variable, temp, and then change it to y, then change y to temp. This is one way to achieve swapping. Okay, when you want to swap two variables. Then in addition, in Python also have a simpler way. This way now, this approach, any day, anytime you are asked to swap or you need to swap in any language you are, this approach will work. But within the Python space, there is another approach that makes it simpler, which is x, y equal to y, x. See this syntax? This looks very simple, right? You don't need the holding variable. Once you do this, it's going to swap it. So you just x, y is equal to y, x. X now we take the value of Y, and Y we take the value of X. That's it. So that's for swapping. So I'm sure by the time you go through the exercises, there will be some exercise where you need to swap some values. Then you can use these two approaches to swapping. Okay. Is it clear? I think it's quite
Yes.
simple, right?
Yeah.
Now that's it. Programming is simple. But now you see the challenges if you don't do the exercises. Now, when you go and read some of those exercises, you don't just solve them as simple as swapping and counting and summing like this. You, in solving them now, you use other tools you've been equipped with from chapter 1 to this point, right? Those questions will make you use everything. Now, if you're not used to if statement, where you are supposed to use if now, it will be giving you a challenge. Okay. But then if you've been doing it, you will now see that these are just additional tools that will come in to your solutions. And then, well, for instance, when I did sum here, I brought for loop, I brought if, and then the sum happened. If you don't know if, maybe you've not practiced to understand how it works, you then have a challenge. How do I evaluate the condition? Your for loop, how do I use a loop to generate the numbers or anyhow you want to do it? So just like building a house block by block, every small concept we learn is simple, but it's a building block and we are forming something. By the time we go, you'll be amazed the amount of concepts you'll be bringing out from your head to solve problems. Okay, so the next one is flag variables. Now, in some instances, we need to flag something. When you talk about flagging, you're just basically saying true or false. True or false kind of flag. So if I say this toilet is for only females, right? And people are entering. The moment a man enter, where you're not supposed to enter, a flag now, maybe it's checking everybody as they enter. Once you just see man, that flag will just go up. Are you getting just like alarm glow? So that's kind of like the concept of what flag variable is. So I can be checking a set of numbers and say within this set, whenever I see an even number, I need to stop it or I need to highlight it because I don't expect even numbers to be here. But once it's there, I need to highlight it. So in highlighting, you can use flag. So the same thing with counting and summing, you initialize your flag in the beginning. If you want to say your flag is false, right? False with capital, yeah. Flag is false. Now you then evaluate the condition. You evaluate the condition. For instance, let me just give a condition to throw more light to it. Let's say we are going through the for loop. We have let's use for loop for I in range 10. Let's say 10. Anytime I see a number, yeah, if I mod 7 is equal to 0. So anytime I see a number that is divisible by 7, I should just flag it. And that flagging now, you just come and change our flag to be equal to true. Okay, I'm just giving you a rough example. So you have a process you're checking. Whenever a condition occurs, you just change the variable to true. Then maybe in the end of your analysis, you then check again. If flag is equal to true, then do this. do something else. Do something else. Okay? Do we understand this?
Yes.
Absolutely, it's quite understandable.
Yeah, okay. So that's flag variables. It's just a concept. You're just trying to check something. If it occurs, you quickly change your flag from false to true. You could start with true, depending on what you want to achieve. You may want to say, okay, at the beginning, I believe that all the people that are entering, I use the toilet example now, all the people that are entering this toilet are women. So maybe a question, is it a woman? In the beginning is true.